A 50 kilogram sprinter starting from rest runs 50 meters in 7.0 seconds at constant acceleration. What is the magnitude of the horizontal force acting on the sprinter? First off, the column on the left is the problem worked out, the middle is the notes of how the problem was solved, and the far right is the definition of each variable involved. Before we find the horizontal force, we must first find the acceleration of the person sprinting. We could do so by using the following 2D kinematic equation. Luckily, we can simplify a few things to make it easier to solve. First off, for the initial distance, we could put it as 0 meters, as that will be our starting position. After that, we also plug in 0 meters per second for the initial velocity, because we are starting from rest. After that, we get 50 meters is equal to 1/2 of acceleration times 7 squared, which will equal 49. Once we redistribute by dividing 49 on both sides and multiply 2 on both sides to cancel out the 1/2 on the right side, we get that 50 times 2 divided by 49 equals 2.04 meters per second squared. Now that we have the acceleration variable, we can find the horizontal force. Because we can assume that the sprinter is in constant acceleration, we are able to use Newton's second law, which states that force equals mass times acceleration. Now that we have an equation, all we must do is plug in 2.04 meters per second squared as the acceleration value and 50 kilograms for the mass value. And we get horizontal force value of 102 newtons. What is the sprinter's power output at 2.0 seconds, 4.0 seconds, and 6.0 seconds? If you'll recall from the lectures, the power equals the derivative of work in relation to time, and that will equal force times velocity. If you recall, velocity is equal to acceleration times time, so we can change the equation to force times acceleration times time. If we plug in all the time variables, then we get 416.16 for 2 seconds, 832.32 for 4 seconds, and 1248.48 for 6 seconds. You may be wondering, why can't we just use force times distance divided by time, or 1/2 force times acceleration times time squared divided by time? First off, if we were to use that equation, we'd get values that are half the number that they were in the previous slide. So which do we know how to do? Well, it's very simple. Power is meant to be the derivative of work in relation to t. So force times velocity is a reasonable equation, but 1/2 times force times acceleration times time squared divided by time, not so much. Key learning points. Power equals force times velocity, and power is also the derivative of the work equation in relation to time.